Now we will understand the application of Heron's formula in finding areas of quadrilaterals. So far we have read that Heron's formula can be used to find the area of triangle. Now whether the same formula can be used to find the area of quadrilateral, the answer is that Heron's formula cannot be used directly to find the area of quadrilateral. However, in those cases where all the sides of the quadrilateral have been given and the length of diagonal is also known to us, this is the diagonal and this is also known to us, then the quadrilateral stands divided into two triangles. In this picture you can see that quadrilateral stand divided into two triangles. So here we can use Heron's formula to find the area of one triangle, then another triangle, and by adding the area of these two triangles, we will arrive at the area of quadrilateral. However, there are other formulas also that can be used to find the area of quadrilateral depending on the shape and properties of the quadrilateral. For example, in case of a parallelogram, here it is parallelogram, you can see that in that case area can be find out by multiplying the base with height, whereas in the case of trapezium, area is equal to half into long base plus short base into height, whereas in the case of square area is equal to side square. So now we will find out the area of quadrilateral, and we will also here take the help of Heron's formula. Let us see. The question before us is, there is a quadrilateral with each side of 100 meter and the diagonal is 160 meter. Find the area of quadrilateral. So here we can see that the quadrilateral stands divided into two triangles with the help of diagonal. So here you can see that all the sides of the quadrilateral are equal and the diagonal which is passing through the quadrilateral has also been given. So all the sides of both these triangles are equal. In case of ABD, the sides are 100, 100 and 160. In the case of BC and BCD triangle, the sides are also 100, 100 and 160 meters. So all the sides of the both the triangles are equal to one another. So we can say that area of quadrilateral ABCD is equal to triangle ABD plus triangle BCD. So in this case quadrilateral ABD is equal to BCD because all the sides of the triangles are equal to one another. So first of all we will find out the area of one triangle. Here we will take the area of ABD. We will calculate the area of ABD, triangle ABD. We will use Heron's formula. What Heron's formula says? Heron's formula says under root S into S minus A into S minus B into S minus C, where S stands for semi-perimeter, A stands for length of side A, B stands for length of side C, side B. C stands for length of side C. Semi-perimeter is equal to half of perimeter. Perimeter is the total of all the four sides, total of length of all the four sides. Or we can say that perimeter is, in case of triangle, is equal to the length of three sides of the triangle. So here perimeter is equal to A plus B plus C divided by 2. So here we will fill in the values. What is the value of semi-perimeter? We will see that perimeter is equal to, here we are calculating the area of AB and ABD triangle. So value of A will be 100, 160 and 100 divided by 2. This is 100, this is 160, this is 100. So it will come as 360 divided by 2 is equal to 180 meter. So this is the value of semi-perimeter. 180 into 180 minus A has been taken as 100 into 180 minus B has been taken as 160 into 180 minus 100. So because C has been taken as 100. So what is comes 180 into 80 into 20 into 80. So here we will here do prime factorization. What is prime factorization? Prime factorization is a process in which we find out the prime numbers. Prime numbers are those numbers which are more than 1 and which can be divided by the number itself and 1 only. The examples of prime numbers are 2, 3, 5, 7, 11, 13, 17 and so on, because these numbers can be divided by themselves and by 1 only. This is only for your reference. So we can say that 180 can be divided into 18 multiplied by 10. 18 can be further divided into 9 into 2. 9 can be further 3 into 3. 10 can be 5 into 2. So these are the prime factors: 3, 3, 2, 5 and 2. These are the prime factors. So here we will write 3 into 3 into 2 into 5 into 2. We take these as it is, because these will become square and will come out of under root. This is, here we can divide 20 into 10 into 2, 5 into 2. So 5 into 2 into 2. So here what we understand, this is the square, this is square, this is square, this is square, this is also square. So when these come out of the under root, we can write it as 3 into 2 into 80 into 5 into 2. What it comes? 4800 meter, square meter. This is the area of one triangle. We have find out the area of this ABD. It is 4800 square meter. So this is the area of one triangle, but because the sides of other triangle, that is BCD, are also the same as ABD. So the same is also true. What the area we have calculated for ABD is also true for triangle BCD. So area of triangle BCD is also 488 square meter. We have already found out the area of ABD, that was also 4800 square meter. So the area of quadrilateral ABCD is 4800 plus 4800, because this is the total of triangle ABD, this is the area of triangle BCD. So answer before us is 9600 square meter. This is the area of triangle, area of quadrilateral ABCD is equal to total of both these triangles, and we will arrive at the area of quadrilateral. Thanks for watching. If you like our course, please spare some time to give a star rating to our course.